Hi, good day. I'm Jason. I'm the CEO and co-founder of ProMake Limited. We originally started the business out in South Africa, in Johannesburg. Background is that we originally come from a 3D printing and a additive manufacturing sector. But since then, we've been advanced to the point of having our offices set up here in Manchester now, and we've now developed a full team. So what is it that we actually do? ProMake Limited is a smart materials and smart devices entity. And how we do that is quite revolutionary in many aspects, because we've taken material science, we've taken innovations through additive manufacturing to be able to create really smart devices and products. In order to do so, we have built a strong team with Gavin Leggett being our COO, our Chief Operations Officer, Gemma Bethel being our Chief Marketing Officer, and Karan Mahadev as our Chief Financial Officer, so that we can create a structure that is really world-class, because in order to do what we do, we've had to think beyond and even beyond that. And a lot of people say that goes into the world of full-on imagination. But as we say, if you live in a world of imagination without belief, essentially it's just a dream. But we believe that we can do what we do, and we do make it happen. So how do we do it? So we want to create a fast, cost-effective supply of tailor-made solutions to raw materials. Now, for most of you that understand additive manufacturing, or what is classed as 3D printing, is we take the 3D printing world of consumables and polymers and actually combine them into a smart material. Now, to be able to do that, we wanted to take 3D printing as we know it and take it from the 3D world and then put it into more what's now heard of is the 4D world. So bridging the gap between the two to be able to create the smartest innovations through additive manufacturing. The thing is that most materials that have been developed in the past have always been used in third industrial revolution type processes, and whereas material was really just there to fulfill a structure, and to fill a function in a sense of its shape. What we're doing is we're now going to the point of now taking 3D printed parts by pre-programming the material to make a smart 4D revolution in 3D printing. So in order to do that, we had to come up with a structure and a process with utilizing a so-called graphene, as you heard about earlier from Geek itself, where we could process our materials through an enhanced surface engineering, but not by utilizing anything that is controlled with an acid-based treatment, so that our products are also environmentally friendly. It's all good and well making great product, but if it doesn't fit the bigger spectrum of things and it helps save the environment, as our core purpose is, and helps save humanity, we're not really competing in the right sector. We want to be able to make something that betters lives. We want to be able to make it adaptable for all markets, not just for one sector alone, but be able to take it to the level that we're improving segments for the better of humanity. So this makes us and gives us a better advantage in our feedstocks, essentially what our material is and how it will take us to the next level. So in order to do that, we had to go take a project where we would really push the boundaries beyond revolution. And what we did was, in early 2019, we did the world's first 3D printed inner ear transplant. And how do we do that? We did it by reverse engineering the tiny little ossicles, the tiny little bones inside your ear, by reverse engineering them and through utilizing 3D printing, but then also harmonically tuning it. So we pushed it from a physical structure into the 4D world by harmonically tuning it so it matches the patient's resonance. So by doing that, when the sound comes through the ear, vibrates against the eardrum, the harmonic frequency of the inner ear transplant will then vibrate correctly on the right resonance to be able to feed the information across to the cochlea. So that way, most of you have heard and seen the hearing aids that most patients will wear, especially you heard the term harder hearing. This helps with that harder hearing process by kind of making it an organic fixture without any electronics, by reverse engineering nature's ability to produce sound waves through a harmonic frequency that runs through the inner ear transplant. This set us on a world stage. We got put into the same category as the first heart transplant in South Africa, which Chris Barnard did many years ago. But then we were ramping up very quickly, and then lo and behold, COVID hit us. And that was, so what do we do now? Because we aren't able to now take our research and put it into areas of inner ear rehabilitation, essentially, or in trying to combat deafness globally when COVID has now become the forefront. So we took all that research, all that information that we did, and we said, well, we need to take it to the next level. And what can we do with graphene that could potentially take us to the next stage? So by concentrating and changing our business model a lot around the use of graphene and how we can called pre-program our material to perform a particular function before we turn into physical shape was where we set ourselves out to. So Gavin and myself and the team spent long hours, long nights working out the new algorithms so that we could potentially make a world-class material or world-class process that could then be fed through our 3D printing machines. This opened a whole spectrum of new possibilities, new innovations, but like any idea is, where do you start? And you've got to start somewhere and start simple. So one of the areas that we work closely with is obviously prosthetics. And as you have seen, many pro athletes wearing a power-loaded prosthesis such as this one, which is normally made from composites such as carbon fiber, is made from metals, and different types of elastomers. Now, by doing that, it's all good and well. Yes, you can get a strong prosthesis, you can get a nice power load, yes, all of that. But we wanted to take it to the next level. As you can see in the picture, when a person runs, your good leg will have an so-called explosive load release. How much power can that muscle in your leg release? The problem is now, how do you match a prosthesis to be able to give the exact same power load and power release? So essentially, when a person's running, they have a scenario where one leg is striding out the other, and you kind of have your prosthesis trailing behind you, and hopefully you can get a nice balance. So now being able to pre-program our materials, utilizing 3D printing to create the construct, we are now able to pre-program the prosthesis to be able to have the same power load release through certain conductive elements that we create within the polymer itself. So when the athlete runs, he now can have symmetry in his stride, being able to have the same power release. Now, if you think about a prosthesis is so many sectors all into one. It's engineering, it's design, it's aerodynamics, it's constructural from an impact and a pressure point, automotive from a stress loading point of view. There's a lot of segments, so we decided to go with prosthetics so that we can then innovate new products as spin-offs into other segments, such as, so as you know, we did with the inner ear surgery, we decided, well, what about prosthesis? What happens if we can actually now create harmonic resonance from prosthetics that go on the outside together with the inner ear surgery so that we can actually not only give the person that's missing an ear from a previous trauma or birth defect to be able to give them a commercially acceptable or a socially acceptable look and feel, but also then give them the social acceptability to be able to say that they can hear properly and not stand there looking great but actually can't hear. So we decided we'd go with that also and look at ways forward. This opened more doors for us. So we said, well, what happens? What if, and I pose this question to you, what if we're now able to take it to the world of linking organic and digital together by simply putting forms of biomedicine techniques into, as well as things such as AI or machine learning, by kind of linking prosthetics so that you can get feedback to the brain, feedback to your tissue, feedback to your nervous systems, so that you're now no longer seen as a disabled person, but more as a functional person because you've got control over your own functionality. So we started to pioneer ways that we can now take 3D printing, combine it with functionality together with the 4D realm of fine-tuning the materials. So we set out a task to be able to do this. We then developed together with Geek a new material which will then be able to make it so-called functional in many aspects, together with our business partners, Haydale, who have a fantastic way of now helping us functionalize our materials. What this does do now is now we're able to make smart and custom smart implants, smart prosthetics. There's a whole range of thermo and electrodynamics that we're able to link to a patient's bio, essentially. So being able to read the temperature of a person's body, the so-called sweat output of their body, or even the conductivity of soft tissue. So that means we're no longer looking at just the external properties of a patient, such as an external prosthesis. What if we can actually put this inside a patient? Because you think about it, carbon fiber, graphene is carbon loaded. So what it does mean is that your body won't reject it because essentially it's a carbon molecule. And you can actually start adapting it based on the science of your human spectrum. So we set out a way to be able to functionalize our graphene so that we can now start looking as an external source as well as an internal source. So what that does mean is that we're now starting to merge biomedicine with digital medicine. So what we've been doing is, years ago, we utilized the technique actually to help fix me, put me back together after a bad accident. And one of the things that we worked on is we developed a way of incubating bone inside my shoulders to be able to regrow the bone, because the accident was going to leave me with the point of having to amputate my shoulder, my arm at the shoulder. So in order to do that, we need to be able to make a way to harmonically make the bone conductive, so that we can actually increase the growth of the bone utilizing what we call a BMP, which is a osteogenic bone matrix. So we took stem cells, bone matrix, and at that stage we used nanosilver, but now we're converting it across to graphene, so that we can actually speed up the osteoblast regrowth within the bone itself, so that we can heal such as osteoporosis, bad breakages, birth defects, through scaffolds that we can 3D print. So we can actually make bone grow through the scaffolds and then incubate the body incubate the bone inside the body, so that we're no longer reliant completely on titanium implants. So we worked along on this lines to be able to now make the world a better place in respects of not having to always have amputations. I'm standing here today because of this, with no amputation to my right-hand side, because we had the opportunity to do so. We now are making this an opportunity for multiple others. Going a little bit further, we realized that in order to help patients, the big problem with titanium is that it gets cold in winter, it's heavy, sometimes you have fitment issues. But with the digital aspects of utilizing MRI scans, CT scans, and converting a CT scan into a digital CAD file, we can now able to do surgical guided systems to make sure an implant is custom made for a patient, so that it can be implanted to the highest accuracy. But not only that, be able to then give feedback of to how that implant is going to be working once it's inside the patient. So instead of having to go and just do snapshot x-rays, we're now able to then do live monitoring on a patient going forward without having to do an invasive procedure. This again gives the doctors a lot more information as to how your bone is performing, how the implant is performing, to try and prevent issues before they even happen. Because you probably heard about it many times about a patient that's had a hip implant or a knee implant that's broken out. We're trying to prevent that happening by utilizing the prosthesis that's implanted, or the implant that's been implanted, so that we can give a live feedback, so that doctors know how to correct situations. Because sometimes it could just be a diet that's breaking down the bone. You might be suffering from celiacs, and you might not be absorbing enough calcium. And these are issues. These are major issues that you can't tell otherwise. So by making smart implants, we're able to make smart interactions to be able to help the doctors make the right decision going forward. So as we mentioned, by linking up to AI, what that does mean is that no matter where you're in the world, whether you have a surgery in the UK, surgery in the States, or in South Africa, you would then be able to go and get live feedback, give live feedback to the surgeons that you're seeing, should you pick up any complications. But also then you'll be able to know where you stand physically. So instead of waiting for a doctor to always just tell you where you're at based on assumptions of his skills, and don't get me wrong, doctors are highly skilled for a particular reason to tell you this, but this helps give validated information as to what can potentially go wrong or is going right. And you got information on a live feed for that. What it also does is the smart implants will help us with machine learning. So we're getting live feedback through a cloud-based system, so that we can then better implants, better genome sequencing, to be able to make the implant match patients better based on your biomolecular standards or structures. We're now pioneering a way to be able to bring the analog world and digital world together, so that we can better your life for longer longevity, so that you're not left in a situation where you feel like you've been shortchanged because you've had an injury and the world sees you as different. I know, I went through this. I know what it's like. And people do judge you, and it's sad. But we're now trying to give people not only life back in a mobility point of view, but life back in a social realms. And this is where our main aim is, to be able to constantly thrive to better humanity as a whole. So where are we taking it now? So you've heard of, as I said, we've heard about 3D printing and 4D printing, but to what level are we going? We're now going down to nano level. So what this does mean is we can make items that are like 10 microns in diameter, which that is 0.01 of a millimeter. It's tiny in a structure, but we're now doing it nano printing, combining with graphene. So that means we're looking to now be able to join nerves back together, to be able to do sensory systems that go into your muscles, can go into your brain, so that for stroke patients, for heart attack patients, for cancer treatments, not just for humans, for veterinary and for cattle, and there's just so much that can be done, but in a way that it doesn't create invasive means. You can do this through keyhole surgeries. There's a whole range of applications. So do we need to do the old school way of surgeries? if we can do a monitoring system beforehand. So it's a pre-recovery process which we're working on, so that we're able to analyze you way before you actually even have your surgeries or you have a condition, so that we can create a blueprint construct of who you are, so that from there we make the best implants, best procedures, and best ways forward. But by doing this, we're not looking to be able to do it purely for ourselves. We're now looking to collaborate, because Manchester is all about collaboration. And this is something that we've adopted as an entity globally, to be able to make collaborative means of sharing our information with other surgeons, other engineers, other technicians, so that we can take this to a new realm. And by doing that, we've now found certain areas in 3D printing that puts us into a whole new spectrum of where we can take it. There's a range of printing machines and printing partners that are on the market at the moment, but where ours sits into is a very, very low spectrum point where there's not a lot of research being done. So we're really pioneering an area that is exciting, because if we don't do it, where will the world be in the next few years if we don't take this to a whole new level? We want to be one of those entities that take us to the realm of leaving a legacy, not because we want to claim the glory, but just so that we can make a better humanitarian lifestyle. So one of the projects we're busy working with is cardiovascular stents, to be able to monitor things such as your glucose levels, your cholesterols, be able to help, if you've got a heart defect, or you've had a heart attack, or you've had a bypass, be able to monitor you live. Instead of you having to go to a doctor, you can do this from home. That's kind of where we're trying to go to be creating an external device that you could be able to monitor yourself that's linked to the cloud. So no matter where you are, you think about it with COVID today, trying to get into a hospital when the hospital's ER and emergency rooms are packed with COVID patients. If you've got an issue, you're on a waiting list to a degree in some countries. We want to be able to take digital medicine to a whole new level, so that you can get monitored from your home at any time by your choosing, and make sure that you have control of your own health. This is what we're trying to do. So, but again, we're making it collaborative. We'd love to hear from you. We'd love to know what your thoughts are. If there's anything you think that could make your lifestyle better, let us know. We'll gladly listen to you. We listen to everybody else, and this is how we got this far. So I'd like to thank you for your time and for allowing us to be here today. Thank you very much.
Wow. Where do you even start with something like that? There was times there that I was listening and thinking, I'm pretty sure I've seen this episode of Doctor Who before. It is that level of sci-fi stuff that is just suddenly coming to life and being used, which is just absolutely incredible. And, we've spoken a bit around, those kind of commercial opportunities for innovation, but that mantra that just kept coming through of, betterment of humanity, betterment of the planet. Is it that keeps you just getting up in the morning and being like, what next, what next? The amount of times you said, what if, in that video just seems to be what you must say to each other all the time. It is.
It really is that. Seeing the beauty of it happen when you do put something in place like that, and how it has bettered a person's lifestyle or the humanity as a group. As I say, like Manchester being so collaborative, the feedback and the excitement and everybody getting involved, you don't see that much today in much industries. And that's really what's been pioneering and gets us going, yeah.
Incredible, and absolutely singing Elevate's tune there in terms of bringing people together, collaborating and doing wonderful things together.